This is neural network-based validation of Valorant match betting odds for the AI class final project. Our problem under study is that within Valorant esports, the published sportsbook odds have no way to be verified. Bettors have no way in determining the accuracy of the sportsbook models or which features are used to figure out these odds, as well as how well these odds actually align with the true outcomes of the matches. And to address this, we built a two-stage neural network using our domain expertise in Valorant and machine learning to see behind the black box that is the match betting odds. There are some existing approaches, like Adrian Lamb's Valorant round win predictor. This specific predictor has a live gameplay feed of a Valorant map that predicts teams' chances of winning based on the positioning of the map. Adrian collected data from a tournament in 2022, and the model was trained using the most played map at the tournament because this would provide the most amount of data. He then automated the capturing of live map data by capturing images every half second, sorting images into folders based on team score, and then told the system to wait 30 seconds for the pre-round or prep phase to end. Then, to count the rounds, the model would simply look at the scores from the provided video, but the only issue was that some of the numbers were difficult to read due to the font that is used in Valorant and some of the text-style things in the game. But with the tournament footage, Adrian was able to capture around 4,500 images for training and 500 images for validation. When training the model, he achieved 99% accuracy in training and 88.6% accuracy on validation testing. To run the model, all one needs to do is pull up the tournament footage and execute the program. You'll see a live line graph that visualizes which team is performing better, and it continues to predict until the program is closed. His model was created with pretty good intent, and it seems to work well with the given scenario, but a very notable downside is that it only really works with the footage it was trained on from that specific tournament. It's a great proprietary tool, but hasn't really been scaled at all. And again, it doesn't really have any way of providing anything more than the prediction for that given match. Another existing approach is from Jeff Kleinitis' Valorant match predictor. He created his own version using data from tracker.gg, and his predictor takes in parameters selected by the user, such as map, rank, and agent selections. And after these are inputted, the program attempts to predict the match outcome. Then, as seen here, the visualizations appear displaying the team's chances of winning, agent pick rates based on the map, and agent win rates based on the map. And his predictor is very good for everyday ranked play, for anybody, really, for majority of people, but for those searching for betting odds, there's not really a clear section providing the accurate odds for esports betting. One could infer from the infographics which team has the better chance of winning, obviously, but the model doesn't factor in specific team statistics or team strategy or player availability that we see from an esports setting.
Hi, my name is Brady Hauglie, and now we'll go ahead and get into the performance evaluation section of our project. To start off, we'll go ahead and define some metrics. So we use log loss, which computes the difference between the negative log likelihood of a prediction and the true prediction, Brier score, which computes the MSE between the prediction and the actual outcome, calibration slope, which fits a linear regression comparing observed against predicted values, raw ROI, which computes the expected percentage return from a bet with fair odds, with positive being the better of the two. Juiced ROI, which computes the expected percentage return from the bet with house odds, model ROI/EV, which computes the average of the per bet profit of the model. And then we'll go into the actual results. So starting off with the advantage bets, the back test. Let's start with the positive theoretical EV. We had an average expected value of positive $0.735 per $1 staked, which indicates that versus truly fair odds, the model consistently spots mispricings. And then raw odds profitability, if the book offered 0 VIG, betting on these 56 picks would yield a 19.6% ROI, turning $56 of stakes into $66.97, which showed that our model may theoretically discover mispricings. To translate positive EV into real-world profit, we would need to increase the model's edge beyond the 8.9% hurdle to overcome the sportsbook house edge. And our model identifies an advantage condition over 90% of the time when the VIG is removed from the sportsbook odds, which means our model is mispriced. Nearly every prediction from the sportsbook is mispriced based on our model, which indicates that our model is overconfident. Then we'll go into advanced bet scoring based on our individual advantage scoring metric results. The sportsbook's implied probabilities outperform our neural network's advantage picks. So log loss showed 0.6873 versus our neural net's 1.1399. Then the Brier score 0.2459 for the sportsbook. And then you can see the rest of the data right there. Altogether, this indicates that when our network marks a large number of bets as advantaged, our results remain far less accurate, less calibrated, and less profitable than the Thunderpick odds under realistic conditions. And then finally, the full sample proper scoring evaluation based on our proper scoring metric results. When we score every match without filtering for an expected value edge, the sportsbook still surpasses our neural net on both proper scoring and profitability metrics. And then overall, these metrics reaffirm that across all matchups, the sportsbook's market odds have better probabilistic accuracy and realistic returns compared to our neural net's predictions. So that's based on our model. Now we'll go into a proposed new approach. Our model performed poorly for a variety of reasons, and over the course of the project, we have learned a lot about what goes into making a solid match predictor model. The main reasons that explain our model's poor performance are training on continuous data, which our match predictor trained on continuous map win percentage labels, instead of binary win or lose labels, which introduce a much higher log loss score when testing against the binary win loss labels. Then data limitations, which were several issues. We started with missing match dates. The VLR data sets that we used from Kaggle didn't include the date of the matchups, which meant we had no way to derive the recent performance of a team. Then missing pre-match odds, which is another issue with the data sets. And then not enough samples. There weren't enough samples because we had to use just the Americas region in order to scrape data for testing, which obviously limited how much we could test on. And then feature limitations, we had map pick information. There were 7 active maps within the map pool at any given time, and teams have map preferences and maps that they perform poorly on, which we couldn't introduce into our neural network or forgot to. And then roster changes. Throughout a Valorant season, a team may drop or change the starting players in their lineup multiple times. If the best team in the league has their best player unable to play, the team's odds of winning should be affected. And then that leads into our conclusion. In conclusion, while our neural network did not beat the sportsbook's odds, it served its true purpose of validating and gaining insight into the creation of sportsbook odds. We confirmed that the features we selected align with those likely used by bookmakers, and that Thunderpick's odds are neither arbitrary nor grossly mispriced. Our open source experiment provides an approach for others to audit the odds of sportsbooks. As esports betting continues to grow, such transparency will help ensure fairness, promote informed wagering, and hold sportsbooks accountable for the quality of the odds they provide. Future work can build on these foundations by integrating live data, refining our feature engineering, and leveraging more advanced neural architectures to bring the quality of open source models closer to the black box sportsbook models. And now we'll lead into our demo.
So I am going to show the steps to install our project as well as run all of our scripts. To install our project, we need to have Poetry already downloaded. The steps to do that are listed. Once Poetry is downloaded, we can do the following. We start our Poetry shell with this command. And then what we can do is run the make install command to download all of the dependencies that we need for this project. Next, I am going to show how to scrape a match odd using our match scraping script. So we will run the command make scrape odds, and what this will do is go to the VLR link and it will scrape the odd that's present on the link. So as we can see, it has scraped the web page, and we're going to go to this links. Notice that the odds are 7.91 and 1.14. When we go to this link, it will be slightly different. So we notice that this Thunderpick text box, it says returned $106 at 1.6 pre-match odds. So this is the actual VIG odd, or the odd that has the house edge built into it, baked into it. But we get the 1.04 by doing this equation, and that is shown in our research paper as well. So that's how we scrape the odds. Also, it's important to note that the odd that is scraped is stored in our scraped data folder, and it will be in the Thunderpick match odds folder. And we see that the one odd that we scraped is there. And the full unrounded odd is listed. Next, I will show how we scrape matches. Similarly, we do the make scrape matches command. And what this will do is, given a specific match URL, it will scrape the in previous matches. It will also scrape the previous head-to-head matches between the two teams. So after the matches are scraped, the data will be stored in our matches scraped data set, as well as our players' stats scraped data set. This contains the matchup and the specific round win and map win percentages, and then the player stats does the same for this matchup that we scraped. And that's how we scrape all of our data. So now that we actually have our scraped data, we can train our model and predict with it. And we can do that with this make model command. So after training our model makes its predictions, now these values are completely nonsense because the scraped data sets only have that one row. But yeah, this is how we train and predict with our model. And lastly, in order to do the hyperparameter tuning, we do the make tune command. And this runs our script to find the best model parameters for our match predictor neural network. And after our hyperparam tuning script is complete, we are given different hyperparameters to use in our match predictor neural network. And once again, these values are just junk right now because of the demo. The data set's not fully completed.